First, let's discuss the purpose of IP routing. We have these subnets represented by these green ovals. In a bit, we're going to talk about what a subnet is. For now, it's a collection of computers that can talk to each other without needing to go through a router. A router connects different subnets, or it routes traffic between different subnets. So whether it's a computer here in the 10.18.164.0 subnet wanting to talk to a computer in the 10.18.165.0 subnet, or a computer in this 10.18.164 subnet wanting to talk to a computer in the 10.23.85.0 subnet, the traffic's going to pass through one or more routers. We're going to talk about how subnets are defined in a little bit, but first let's look at some tools where we can watch IP routing happen. So let's open up a command prompt, and the first tool we're going to talk about is traceroute, and that's spelled T-R-A-C-R-T. So to get started, I'm going to run a traceroute on either a name or an IP address. So I'm going to do a traceroute to pluralsight.com. So this is going to determine what the route is, what the series of routers that this traffic has to pass through to reach pluralsight.com. And it's going to take some measurements on how long each hop takes. So we see that we're passing through 10.0.1.1. That's my local router connected to my cable modem here. And then it passes through some unknown IP address, and then you can watch it geographically move. First it goes through a Comcast router here in San Jose, where I'm currently located. And it passes through Oakland, Sacramento, up to Seattle, over to Denver, and then we see it pass through some unknown locations here, and eventually it reaches a network called Via West. It looks like it's located in Denver region. And so we can see here's all the hops that our traffic had to take to get from my current location to the pluralsight.com web server. These numbers here in milliseconds represent how long each hop took. If we're having some type of routing issue, we might see extremely large numbers or even timeouts on various hops along the way. Now, if we were to find a link that was bad, there's really nothing we can do, especially as a developer, but even me as a systems engineer. The routing happens by, high-level network professionals, but it's just good to be able to diagnose this information, and it can give you a possible clue to possible issues that are happening. Let's take another traceroute. I'm going to take a traceroute to sevans.info, just so we can see a different path across the internet. So here we start off with my local router. Through San Jose, Oakland, Sacramento, down to Los Angeles, and into a network owned by DreamHost, where I host my website. So we can see much fewer hops, lower route times, so slightly better performance. But when you think about this geographically, we're going from San Jose to Los Angeles, a distance of about 400 miles, compared to San Jose to Denver, a distance of, a couple thousand miles. So this brings up one interesting point. If you have traffic, a lot of users that come from, say, Europe, you may want to place your web servers on the east coast of the United States so that it's geographically centrally located between your Western United States and European customers. So traceroute is helpful. It gives us a snapshot in time, but there's another tool called pathping that can give us slightly more detailed and robust reporting. So I'm going to run pathping with the exact same arguments. So let's do pathping to pluralsight.com. And so it's going to find that same route again. Now, if you're doing the same demo at home, you're going to find different routes. Routes change throughout time, and also from your location, you're going to have a different route from wherever you're located compared to where I'm currently located. So here we are. It finds the exact same route, and then it's going to perform a series of tests on these links over a long period of time. So it's actually going to hit every single link 100 times and then report on some statistics. So we see here it's going to take 400 seconds for this test to complete. So it's going to take longer, but it's going to give us more reliable and accurate results. So here we are, through the magic of editing. I turned that 400 seconds into about 4 seconds. And here we have our results. If we scroll up to the top, we see it shows us which hop it was, the round trip time, and the number of lost packets it sent out of 100. So it's lost 0 packets out of the 100 it sent. And that's true all the way down the line. So we have a nice healthy connection here. So we've had 0 lost packets. And so this is exactly what we should expect to see in a nice healthy connection.